Hello everyone, welcome to the OneClass channel. My name is Marlyn. I'm a second year student at the University of Waterloo studying chemical physics with a minor in math. Today I'm going to be going through some high school level and college level algebra problems. Be sure to check out the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, so for our first question, we'd like to figure out how to factor this expression. So we have been given x to the power of 4 minus 8x squared minus 9. So how we're going to deal with this is we're going to set this as a quadratic because you know how to deal with quadratics. And so if we set x to the power of 4 is equal to u squared, and we set that x squared is equal to u, we can rewrite this expression as u squared minus 8u minus 9. And then we can treat this using product sum, or we can use the quadratic formula. I'll explain how to do both. So first, for product sum just states that for the expression au squared plus bu plus c, I would like the sum to equal b and the product to equal ac. In my case, AC is going to be -9 and B is going to be -8. So what two numbers can I add to get -8 and multiply to get -9? And those two numbers are going to be -9 and 1. And so my solutions to this will be u squared minus 9 and u squared plus 1. Now I can confirm this using the quadratic formula that just states u is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. My b is -8, so this becomes 8 plus or minus the root of 8 squared, 64, minus 4 into -9 into 1, all over 2 by 1. So this will become 8 plus or minus the square root of 100 all over 2. And this will become 8 plus 10 over 2, so 18 over 2, and that is going to be 9. Or 8 minus 10 over 2, which is -2 over 2, which is -1. So I have the two solutions, u is equal to 9 and u is equal to -1, which when I isolate the 0 to one side, I get u plus 1 is equal to 0, and u minus 9 is equal to 0, which is exactly what I got using the product sum method. You can choose which one you'd like to use based off of your coefficients here. If the coefficients, it's easy to figure out what your two numbers would be in the product sum case, then go ahead and use that. But if it doesn't come to mind quickly, which would usually indicate it's complex valued or decimal, then go ahead and use the quadratic formula. It's the safest bet. It just takes a little bit more time than the product sum method. Okay, and so my solution to u squared minus 8u minus 9 is u plus 1 and u minus 9. Now I come back up here and I need to remember that u represents something. And so u represents x squared, so I'm just going to go ahead and put that right back in here. And I'll get x squared plus 1 and x squared minus 9. Okay, now, because the initial expression we're given is to the power of 4, that means that the order is 4, and I can expect 4 zeros. These could be real, these could be complex valued, it depends. And so in the end I should have 4 brackets when I factor it. And so currently I have 2, which means I'm looking for 2 more. I can already see here I have a difference of squares that I can deal with to separate into 2 brackets. Here, I wish I had a difference of squares, but I don't. Instead, I have addition. And addition usually indicates that we're going to get something complex valued in this case. So let's go ahead and do that. So for x squared minus 9, I'm going to apply the difference of squares, and that just states that a squared minus b squared is equal to a plus b into a minus b. You can confirm this by just doing FOIL to expand it out. My apologies. So it'll become a by minus b, b by a, b by minus b, and that will become a squared minus ab plus ab minus b squared. These two cancel, of course, to form a squared minus b squared. So that's just a quick proof for that. And so now in our case, so in our case, we have, just erase this. Okay, so in our case, we have x squared minus 9, which is the same thing as x squared minus 3 squared. And so that means our a is x and our b is 3. So this will become x plus 3 multiplied by x minus 3. So we've split this into, x plus 3 by x minus 3, and this one we haven't dealt with, so we have x squared plus 1. You could technically leave it like that. When you add up all the powers of x, you still get the 4, but this isn't the completely factored down version, so let's go ahead and find that. And we're gonna apply quadratic because, as I said, I can already tell I'll have a complex valued solution, and so it's best to just use quadratic, as I mentioned before. And so for x squared plus 1, recall it's ax squared plus bx plus c. So in my case, I have a is 1, b is 0 because I don't have a bx, and c is going to be 1. So when I put that all into my quadratic formula, so negative b plus or minus b squared minus 4ac all over 2a. This is going to give me negative 0 plus or minus the square root of 0 squared. So the fact that there is no b is what is making it complex valued, and then the c is positive. So it's going to leave minus 4 by 1 by 1 all over 2 by 1. So this is the 0, it's going to leave the plus or minus the square root of negative 4. So complex valued, I'm taking the square root of a negative number, all over 2. I need to remember the property of square roots that just states that the square root of a times b is the same thing as the square root of a multiplied by the square root of b. So I'm going to apply that and pull out that 4. So I can get plus or minus the square root of 4 times the square root of negative 1 all over 2. Square root of 4 is 2. So plus or minus 2 root negative 1 is a special number that we call I over 2. The 2's cancel, leaving plus or minus I is equal to my x in the case of x squared plus 1. And so this means that x squared plus 1 is the same thing as x plus I, x minus I. So yes, it's technically a difference of squares, but your second number is negative 1 squared is another way to look at it. And so let me just explain the quick way to get to this without having to do the quadratic formula. So I have x squared plus 1, and I recall that the difference of squares says a squared minus b squared. And so I can rewrite this in this form as x squared minus negative 1, right? And then this would have to be a square. And so I can write it as x squared minus the square root of negative 1 squared. So in that case, what I have is x squared minus I squared. And as I said, it will just become x plus I, x minus I, and that's purely according to the difference of square rules and just recognizing that this plus 1, I can rewrite it in a form of -1, figure out what squared is -1, and so it's the square root of -1 squared. And so that leaves me with x squared minus I squared, so x plus I and x minus I. And so lastly, we're just going to want to put this all together. So as I said here, I have now found that this is equal to x plus I, x minus I. And so I'm just going to come all the way down here and write a clear solution that x to the power 4 minus 8x squared minus 9 is going to be equal to x plus I, x minus I. We found x plus 3, x minus 3. And that's going to be it for this question. Okay, next up we have another factoring question. So let's go ahead and deal with this. So I would like to now factor 2x squared plus 3x plus 1. So as I mentioned, typically I have two ways to answer this question. I could use product sum or I could use the quadratic formula. Now I need to make a note here that product sum becomes not tricky, but it's easier to end up wrong in the scenario where my coefficient a is non-zero, because product sum is going to give you two numbers. Let's call them m and n, and what you're going to put in for those two numbers as the solution. Typically, what you're used to doing when you use product sum is just putting in x plus m and x plus n. But as we know, if I multiply these two x's, I'm just going to be left with an x squared. So it's easy to forget that you had a non-1 coefficient before the x squared. So the best method to use when you do end up with this is a quadratic formula. It's guaranteed to give you the correct answer. I don't need to think about what the coefficient in front of the x squared is. I can just go for it. So first we're going to apply that method, and then I'm going to show you how to use it with product sum, and lastly the one that is done below here. So with the quadratic formula, I need to remember ax squared plus bx plus c. Quadratic formula states that it's negative b plus or minus the square root of b squared minus 4ac. And this is all going to be over 2a. So let's go ahead and plug in our values. I have a is equal to 2, b is equal to 3, and c is equal to 1. So when I plug that all in, I get negative 3 plus or minus the square root of 9, because that's 3 squared, minus 4 into 2 into 1. And that's all going to be over 2 by 2, which is 4. So let's go ahead and simplify this to become negative 3 plus or minus the square root of 9 minus 8, because 4 by 2 is 8 by 1, so remaining with 8. So 9 minus 8 is going to give us a 1. So the square root of 1 over 4. Square root of 1, we know is just equal to 1, because 1 squared is 1. So this would become, my two answers would be negative 3 plus 1 over 4. That becomes negative 2 over 4, which is negative 1 over 2. And for my second answer, so this is equal to x1. For my second answer, I have negative 3 minus 1 over 4, which is going to give me negative 4 over 4, and that is simply going to give me negative 1, and this is going to be my x2. Recall with the quadratic formula, it's giving you x is equal to whatever it spits out. So I need to move everything to one side so that can be equal to 0, and that's going to give me my 0. So this x1, so x1 is equal to negative 1 over 2. When I rewrite it, it will become x plus 1 over 2 is equal to 0. And for my second one, I have x2 is equal to negative 1. When I rewrite it, it will become x plus 1 is equal to 0. Now, I already knew that I'd end up with a fraction here because as I just said, it gives you x is equal to whatever it is, not 2x, not 3x. It does account for the coefficient in the formula itself, but in the final answer, it'll give you it in this form. And I typically would not like it in this form. Instead, I would like it with whole numbers in this position. So I can rewrite x plus 1 over 2 is equal to 0 by multiplying the entire thing by 2. And this will give me 2x plus 1 is equal to 0. That way my two solutions are 2x plus 1 and x plus 1 is equal to 0. And I can tell when I multiply the 2x by x, I get the 2x squared that I was expecting. And so we can just double check that this is correct. Do your FOIL. And you get 2x squared plus 2x plus x plus 1, giving me 2x squared plus 3x plus 1. And so using quadratic formula does give you the right answer, as I said before. Now let's use a couple other methods that are a bit more straightforward for when you're trying to find the answer very, very quickly, which is typically when this is just an intermediate step in a larger calculation, which it typically will be when you get to the university level. Because this would not be the point. The point is that you know how to use this to get whatever it is that you're looking for in the question. So for our second method, we're going to use product sum. So recall AC, B. AC is going to give me 2, and B is 3. And so I want two numbers that when I multiply them, I get 2, and when I add them, I get 3. My factors of 2 are 2 by 1. So I can just put in those two numbers, 2 and 1, because 2 plus 1 is 3, 2 by 1 is 2. And so it works. And so now I need to figure out which one goes with the 2x, because I know I have 2x plus one of them, and I have 2x with the other one. So this is where I need to be careful, because if you match them incorrectly, which isn't possible when you have an A of 1, you'll get the wrong answer when you expand it back out, and you will get the wrong answer. So we can start by trying in 2, for example. So 2x plus 2 multiplied, my apologies. The other factor is x plus 1. Okay, now when I do this, I can already tell this is wrong, because if I divide out the common factor of 2 here, I'm going to get 2 by x plus 1 by x plus 1, which is 2x plus 1 squared. This is obviously not correct, because x plus 1 squared is going to give me x squared plus 2x plus 1. That multiplied by 2 is not going to give me what I'm looking for. It's going to give me 4x here instead of the 3x that I need. So I can already tell this is wrong. And so now let's try and reverse it. And instead place the 1 with the 2x, which if you've already done the quadratic, as I did before, you would already know that it's the correct answer. So now I have 2x plus 1, x plus 2. Yeah. Sorry, just one moment. Now let's divide out the 2. Yeah. Yeah, so let's divide out the 2 now to leave me with x plus 1 over 2. And x plus 2, which is not what I was looking for, because what I was looking for was x plus 1 over 2 multiplied by x plus 1. And so I can already tell you right here, product sum is not the best method to use when you have an A that is non-1. So let's go about checking a different method. Okay, and so for this third method, it's derived off of the quadratic formula. And what we're going to do is we are going to be making use of so if you recall, when I multiplied these out, I got 2x squared plus 2x plus x plus 1. So what I'm going to do is I'm going to try and get what I have into this form that's easier to factor visually without going through the quadratic formula. So when I have 2x squared plus 3x plus 1, how I usually do that is I would like to rewrite this in a form of ax squared plus bx plus cx plus d, such that a by c is equal to b by d. And the best choice here when I split this 3x is going to be 2x squared plus 2x plus x plus 1. So that's 2x squared, a by c. Yeah, so 2 by 1 is equal to 2, the coefficient here, and 2 by 1 is equal to 2. So I have satisfied this. And so I have split it correctly, and then next up I'm going to factor just by common factors, and I'm going to split it along this line. And so first I factor this plus whatever factor I get for this. And so for this first half, if I factor out 2x and leave in x plus 1, that's going to be the correct factorization for here. For here, there's nothing to factor out, so I'm just going to leave it with plus 1 and x plus 1. Typically, you'll want to factor it such that these two brackets are the same. That way, it becomes an application of FOIL, and I can tell that this is the same as 2x plus 1 multiplied by x plus 1. And so use quadratic if you're not quite good at doing it this way and you have the time. Okay. Use the splitting method if you don't have the time and would just like to do it quickly and you're familiar with factoring such that you can easily FOIL to check your answer or visually inspect to check your answer. But the final answer is going to be x plus 1 multiplied by 2x plus 1. Okay, next up we have a word problem. So with word problems, whether it's chemistry or math, what you need to be careful of is recognizing the information that they're giving you, and ensuring that you convert it into a mathematical expression correctly. And so just highlight the words that you need to when you're reading the question, ensure that you understand the question completely, and then use what you've been given to do the calculations that you've probably been taught in class. And so for this question, I have that the square of a number is 12 less than 7 times the number. What is the number? So in this question, my variable, what I'm looking for, is the number. It's what I've been asked for. So I can decide to call the number x. Okay, and then I just need to note some other important language used here. I have 12 less than the number is equal to 12, the square of a number, so the square of my number is equal to 12 less than 7 times the number. So And then this is tells me that it's equal to. So the square of a number, x squared, is 12 less than 7 times the number. So 7 times the number, and then I take off 12. Okay, and so now I just put that all together and I get x squared is equal to 7x minus 12. So convert it into the correct mathematical form. Ensure that you don't change the meaning of what they've said at all, or you'll get an incorrect answer. And then now I just solve for x using what I know from class. So I have x squared minus 7x plus 12 is equal to 0. And so, as I said earlier, my coefficient this time is 1, so I can use product sum. We're going to go over it with the quadratic formula 2. So AC, B, my AC is going to be 12, and my B is negative 7. The factors of 12 are 4 by 3, 6 by 2, 12 by 1. Okay, and please note that this also includes negative 4 by negative 3, negative 6 by negative 2, negative 12 by negative 1. So can I add any of these pairs to get me negative 7? Yes, I can. I can already see it. Negative 4 plus negative 3 is negative 7. So my two factors are going to be x minus 4 and x minus 3. If you'd like to factor it out, you'll get x squared minus 3x minus 4x plus 12, which is x squared minus 7x plus 12. And so my number x is equal to 4 or 3 if I solve for x in these two cases. So x minus 4 is equal to 0 means x is equal to 4, and x minus 3 is equal to 0 means x is equal to 3. Additionally, let's just run through quadratic. So we have negative b plus or minus b squared minus 4ac, the square root of all of that, all over 2a. In my expression, I have a is equal to 1, b is equal to negative 7, and c is equal to 12. So let's just go ahead and plug those in. So I get 7 plus or minus the square root of 49 minus 4 into 1 into 12, all over 2 by 1. This will give me 7 plus or minus the square root of 49 minus 48. 4 by 12 is 48. All over 2 by 1. This is going to give me square root 1. So this will give me 7 plus or minus 1 over 2. So my two x values will be x is equal to 7 plus 1 over 2. This will give me 8 over 2, 4. My second one will be x is equal to 7 minus 1 over 2, giving me 6 over 2, giving me 3. So my final form will be, this means x minus 3 is equal to 0, and this means x minus 4 is equal to 0. So my two brackets will be x minus 4 by x minus 3 is equal to my function. So my two solutions are x is equal to 4 or x is equal to 3. And that's going to be it for this question. Okay, next up we're dealing with some logarithms. So there are two ways that you can be given logarithmic expressions to solve. You can first be given it in the form log to the base of a, m is equal to log to the base of a n. Typically, the thing that you're being tested on in these forms is you will not be given this in the simplified form because you just know that m is equal to n if they have the same base. The second form that you can be given the question is in the form log base a of m is equal to b. And when you write that in exponential form, you get a to the power of b is equal to m. And so you should know how to work with questions when you're given them in either one of the two. And so for our first question, for this question, we have log base 4 of 8 is equal to something. We're going to call that something x, and x is the variable that we're looking for. Okay, so obviously I can tell that this is the second form that I have here. It would be great to leave it like this, but I can't evaluate this without a calculator. So I'm going to change its form into something that I can evaluate on my own, and that is 4 to the power of x is equal to 8. Now I need to make some notes here. I'd like to write both to their lowest base. So that will become 2 squared to the power of x is equal to 2 to the power of 3. Now I can already tell that if I want 2x, I'm going to apply an exponent rule here, and that just states that a to the power of b all to the power of c is equal to a to the power of b by c. And so when I apply that, I get 2 to the power of 2x is equal to 2 to the power of 3. And then I can just deal with their exponents here. And so that means 2x is equal to 3. Isolate for x. And I get x is equal to 3 over 2. And that's going to be your final answer here. There's another way to do this that isn't as straightforward. And that is by noting that 8 is... So 2 squared is equal to 4, 2 cubed is equal to 8, which means that 2 to the power of 3 over 2 actually, let's just forget about this method. The best method to use is this one. It's straightforward, just put it to the lowest base, and then now that you have both bases equal, I can only deal with the exponents and set them as equal to each other and solve for x. Okay, next up I'm being asked for the power of a quotient property. And that just states that a to the power of n over b to the power of n is equal to a over b all to the power of n. Let's just go through some examples to prove that this is true. For our first one, we have 2 cubed over 4 cubed. When I express that out, that is 8 over 64. And this is going to be 8 over 8 by 8, which is 1 over 8. If I had used this form, that would become 2 over 4 cubed. 2 over 4 can be simplified to 1 over 2 cubed. Apply those cubes independently, and it'll become 1 cubed over 2 cubed, which is 1 over 8. So this equality does hold. Let's just do a couple more. Let's try 4 over 2 cubed. That's going to be, squared. Now apply those. That becomes 4 squared over 2 squared, which is 16 over 4. That is 4 by 4 over 4, which is just going to give me 4. This is the same as if I had 4 over 2 is the same as 2 squared, so 2 squared, and that is indeed equal to the 4. So obviously you can tell that the equality does hold, and that this property is true. Let's try 3 over 2 squared. That is going to give us 3 squared over 2 squared, which gives us 9 over 4, which is the exact same thing as if I had, as I've said here, 3 squared over 2 squared. And so it's just used to, typically in algebraic expressions, when you have to like simplify it down, where like you'd be given x to the power of 4 z squared over y to the power of 3 all squared multiplied by multiplied by y to the power of 7 over x cubed as an example, then you'd be told to simplify it. And so first I'm going to apply the power of a quotient property to multiply all of these powers by that 2, and that's just based off of the fact that x to the power of a all to the power of b is x to the power of a by b, because it's not just a 1 in that place. And so applying that, I would get x to the power of 4 by 2, z to the power of 2 by 2 over y to the power of 3 by 2 multiplied by y to the power of 7 over x cubed. This gives me x to the power of 8, z to the power of 4 over y to the power of 6, y to the power of 7 over x cubed. Now I'd like to simplify this down. I'm just going to use the fact that x to the power of a over x to the power of b is the same thing as x to the power of a minus b. And apply that where I see commonality. So I have 2 x's here, and I have 2 y's here that I'm going to apply this with. And so from this, I will get x to the power of 8 minus 3, z to the power of 4, and y to the power of 7 minus 6, leaving me with x to the power of 5, z to the power of 4, y to the power of 1. And that's the simplified version of all of this. And so its best use is in simplifying algebraic expressions. Okay, next up, I would like to rearrange this expression to solve for x and express x in terms of y. Okay, so I have x minus 1, x minus 1, x minus 1 is equal to y. I can simplify this a little bit further to give me x minus 1 cubed is equal to y. Now, if I want to solve for x, I can simply cube root both sides to get x minus 1 is equal to the cube root of y, and then I simply solve for x to give me x is equal to the cube root of y plus 1. And that's going to be it for this question. When you would typically see it is if you're told to find the inverse of a function. Now this, to understand this, you need to know what functions are. And functions just create relationships between two things that seem separate but aren't. Like the time I wake up in the morning compared to the time I go to bed. Those things are related and are in different pools, and I can find an equation that represents how exactly they relate. For example, if x is the time I sleep, then y being the time I wake up, then I can state that y is equal to x plus 12. And this is if I always wake up 12 hours after I go to sleep, for example. And so that's just like a real world example of what functions do. So they linked two pools of data where I have x's and y's, and the function going forward is what I would call f of x. Now, what would happen if I wake up at a certain time and rather I'd like to find out what time I went to bed, if for whatever reason I don't know what time I went to bed? That means I have this y data, but I'd like to find x, which means I'd like to go in the reverse direction, and this is what we call the inverse of the function. So that means when I have y, how do I go about finding x? And just because of notation, I'm going to refer to this y that I now had because it's what I'm using. It's the variable that I am doing things with. I'm going to refer to it as x because x is typically the variable that I'm doing things with. And when it spits out, I'm going to refer to as y, which is why I'm saying here, I want x as a function of y. I want the time I wake up as a function of, I want the time I went to bed as a function of the time I wake up. And so it just enables you to do that, and graphically that just means I'm reflecting it in the line y is equal to x. So when I go about finding it, I can just switch the names of the two variables, or I can leave it like this, and then now at the end say that f minus 1x is equal to the cube root of x, what I'm putting in the time I woke up, so y plus 1. And so let's just see what's happening graphically here in this case. Okay. So for the first function, that's my first function, is equal to y. But now instead, I'd like to have that the cube root, so x to the power of 1 over 3 plus 1. And if I quickly draw my line y is equal to x, I'll see that the blue line, so what I just found is a reflection in the line y is equal to x. So it's the inverse of my initial function. And so it's how I'd go about finding y in this case, sorry, x in this case, if I have a certain value of y. And that's all that's going on with this question. Okay, next up we're dealing with a binomial. Okay, so there is a couple ways to do this. So typically if there's many ways to do something in math, they both represent doing the same thing, but one is derived off of the other just to speed things up. And so let's use, it's always best to know so I call it the basis method, but what the long method is. That way, if you do mess up with these other methods that tend to be quicker and are short forms of this basis method, you can tell when you go wrong, or you can double check with your basis method. And so what everything here is derived off of is going to be the binomial theorem. And that just states that x plus y all to a power is going to be equal to the sum from k is equal to 0 to whatever that power is of n choose k, x to the power of n minus k, y to the power of k. Now, if you're in high school, don't be afraid of seeing new math words, such as n choose k. Typically, it's just can be solved by just an equal sign and written in a form that you're more familiar with. So it's just shorthand notation for something else that isn't quite hard at all. Just because it's new doesn't mean that you should be afraid of it, basically. N choose k is n factorial over k factorial n minus k factorial is what that represents. N factorial is n by n minus 1 by n minus 2 up until you hit basically 1, because you don't want to multiply by 0. It's going to neutralize everything. So as an example, just so you can get more familiar with this, if I had 10 choose 2, that would be 10 factorial over 2 factorial multiplied by 10 minus 2 factorial. That's going to give me 10 factorial over 2 factorial multiplied by 8 factorial. And then you can plug this into a calculator if you'd like. You can also just simplify it. 10 factorial is 10 multiplied by 9 multiplied by 8 by 7 by 6 until you hit 1. That's the same thing as 8 factorial over 2 factorial, 8 factorial, cancel. This becomes 10 by 9 over 2 factorial. 2 factorial is 2 by 1, which is just 2. So that's 10 by 9 over 2. Divide out any common factors, and this becomes 5 by 9, just as an example. So, now let's figure out how to expand this out before we can go about finding what the sixth term is. Because we need to figure out how to expand it so you know what each term is going to look like. So the first term, if I have 5y plus 3 to the power of 10, that is going to be the summation from k is equal to 0 to 10 of 10, choose k, x to the power of n minus k, y to the power of k. Sorry, this is supposed to be 10. And this is supposed to be alpha. And yeah. Okay, so I start summing at k is equal to 0. So my first one is going to be 10, choose 0, x to the power of 10 minus 0, which is 10. Sorry, I need to change these two. My x becomes 5y all to the power of 10 minus k, and my y becomes 3 to the power of k. So my first term is going to be 10, choose 0, 5y all to the power of 10 minus 0, so 10, 3 to the power of 0. My second term is going to be when k is equal to 1, so 10, k is equal to 1. So 10 choose 1, 5y all to the power of 10 minus 1, so 9, 3 to the power of 1. Plus, let's go ahead and write out everything. So when k is equal to 2, 5y to the power of 8, 3 squared. If you can't tell, the power for the 5y is decreasing by 1, for the 3 is increasing by 1, so you can just keep with that pattern instead of constantly saying 10 minus 2, 10 minus 3, so on and so forth. And so you're going to want to go until the power of 5y is 0 and the power of 3 is 10. Sorry. Plus 10 choose 3, 5y to the power of 7, 3 to the power of 3. Plus 10 choose 4, 5y to the power of 8, 3 to, sorry, decreasing by 1, power of 4. And this is going to be our last term. So 10 choose 10, 5y to the power of 0, 3 to the power of 10. Okay, so now that I have this very long expression, the question is asking for the sixth term. So the sixth term, since I start counting at 0, you need to keep mind of that, is going to be when k is equal to 5, not when k is equal to 6, because I start counting from 0, as I just said. So this is going to be my first term, my second term, my third term, fourth term, fifth term, sixth term. So my sixth term is going to be going to be 10, choose 5, 5y, all to the power of 5, 3 to the power of 5. So let's go about finding what this 10 choose 5 is going to give us. 10 choose 5 is 10 factorial over 5 factorial. 10 minus 5 factorial. That's 10 factorial over 5 factorial by 5 factorial. You can just quickly put that into your calculator. You can simplify it by hand. This is going to give 10 by 9 by 8 by 7 by 6 by 5 factorial all over 5 factorial by 5 factorial. Let's cancel out one of those 5 factorials. This would become 10 by 9 by 8 by 7 by 6. And then let's also write out that 5 factorial, 5 by 4 by 3 by 2 by 1. The by 1 doesn't really matter. And then you can just divide out common factors. 5 goes into 10 twice, 4 goes into 8 twice, 3 goes into 6 twice, and 2 can cancel out one of those 2's. And this will leave me with 2 by 9 by 7 by 2, and that's going to give me 252. And so I'm just going to put that right here. This will be 252 by 5y to the power of 5 by 3 to the power of 5. Do not leave it in this form because you're not done. You need to simplify it completely for whoever is marking your paper, or you'll only get part marks. The point is to always make things as easy as they can be for the examiner, because that means you know everything you need to know. So we're going to apply some exponent rules, and that just states that x to the power of a, so x by y to the power of a is the same thing as x to the power of a by y to the power of a, and we're going to use that here. So we'll get 250. So you get 252 by 5 to the power of 5, y to the power of 5, 3 to the power of 5. So 252 into, we're going to use the reverse to bring this 5 to the power of 5 and 3 to the power of 5. So this will become 15 to the power of 5, y to the power of 5. And then you're just going to multiply things out on your calculator, and you'll get 191362500 y to the power of 5. And that's going to be it for this one. Now, the other way to do this question is going to be using Pascal's triangle, which is derived off of Binomial Theorem. But just ensure that you have understood the Binomial Theorem before you can use Pascal's theorem without understanding Binomial Theorem, because you typically taught it on the side in high school, but it's best to know where things come from. So Pascal's triangle, when I'm writing it, I start with a 1 on top, and then 1, 2, 1. From there I can build everything off of addition. So you always have 1s on the outside, so this become a 1. And then I'm going to add these 2. 1 plus 2 is 3, so I put a 3 here. 1 plus 2 is 3, so I put another 3 here, and then I have 1 on the outside. So your outsides will always be 1. Now I do the same thing, 1 on the outside, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, 1. You just continue. And if you haven't noticed, there's symmetry in both of them, which tells you that they're on the same thing. Sorry, that wasn't clear enough. 1, 7, 21, 35, 35, 21, 7, 1, 1, 8. Space things out. We get 1, 8, 28, 56, 70, 56, 28, 8, 1, 1, 9, 36, 84, 126, 126, 84, 36, 9, 1. We get 1, 10, 25, 120, 210, 252, 210, 120, 25, 10, 1. Sorry, this is supposed to be 45. So again, 1 plus 9, 10, 36 plus 9, 45, 36 plus 84, 120, 84 plus 126, 210, 126 plus 126, 252, so on and so forth. Now, the reason I did it all the way until 10, which you don't often see, is because I have the power of 10. And typically the number that you'll see to the power of is the number that you'll expect for your second number. Now, to use the Pascal's triangle, you need to understand how to read it. And so Pascal's triangle is when you have x plus y squared. And so for this first one, since I have 2, I'm going to use that. And so it'll become x squared plus 2xy plus y squared. And so 1, 2, 1. Now the pattern with the powers of what I have inside is similar to what I have in binomial theorem, where the x is decreasing by 1 and the y is increasing by 1. And so I had to go until 10 because my power here is to the power of 10. So I'm going to be using this, and this is going to be my first term, my second term. Sorry, this is going to be, again, start from 0. So this is when x is equal to 0, x is equal to 1, x is equal to 2, 4, 5, sorry. On this one, you can just count until you hit the 6th term. So I have 1, 2, 3, 4, 5, 6. So this is going to be the one that I'm using. And then I additionally need to note this is x to the power of 10, y to the power of 0, x9, y to the power of 1. So I need to know what it's going to look like by the time I'm on the 6th term. So I can just write it out. So I have x to the power of 5, y to the power of 5 is what my two coefficients are going to look like. So that means that if I had x plus y all to the power of 10, my 6th term would have been 252, x to the power of 5, y to the power of 5. But I have 5y plus 3, so I need to put in my x and my y. So this will become 5y plus 3 to the power of 10. My 6th term will be 252. 5y to the power of 5 multiplied by 3 to the power of 5. And then you're just going to do, if you'll notice, this is exactly the result we had up here. And so this will give you the same 191,362, 500 y to the power of 5. That's what it's going to give you. Now, understanding how to use Pascal's triangle is a bit tricky, but once you do, it's easier to use quickly on the back of an envelope when you're trying to just do a calculation really, really quickly and don't want to go through writing out all of them for the binomial theorem. What Pascal's triangle does, if you haven't noticed here, is I got the 252 without doing n choose k. And so these numbers that you see written out here are the n choose k values. And so it's just a quick list of the n choose k. He probably noticed the pattern and made it a thing. And so I got the 252. It's just a pattern of my n choose k, and then you notice the pattern with the x and y's. And so that's going to be it for this question. Okay, next up, I have an exponential question, and I have 5x to the power of 9 is equal to 625. Now I'm going to want to realize that I have two ways to, whenever you see exponential, you can treat it like a logarithmic question, and I can use method 1 or method 2. We call method 1 is when I'm given log base a of m is equal to log base a of n. Or I can use log base a of m is equal to b into exponential form, which is equal, a to the power of b is equal to m. So let's apply both methods to solve our question. We're going to be using a couple logarithmic properties here, so let's just write them down quickly. And that just states that log base a of b to the power c is c log a b, and log base a of a is equal to 1. So using method 1, I am going to want to take the logarithm of both sides, and I'm going to choose the base of 5 because of this specifically. So I'm going to have log base 5 of 5 to the power of x minus 9 is equal to log base 5 of 625. And then here I can note that 625 is 125 by 5. 125 is 25 by 5 by 5. So this will all give me 5 by 5 by 5 by 5. And so this is going to be 5 to the power 4. And this is if like you don't know exponentials quickly off the top of your head, you can just write it out. And so I'll rewrite this as log base 5 to the power of x minus 9 is equal to log base 5 to the power 4. Now I'm going to apply this property. So this will become x minus 9 log base 5 is equal to 4 log base 5. And then I'm going to remember log base 5 of 5 is going to be 1. So these two will both be 1. And this will leave me with x minus 9 is equal to 4. Solve for the x, and you get x is equal to 4 plus 9, and that is going to give me 13. Now using method 2, which is if I decided to use the second form of logarithms, then my method 2 will have me with x to the power of 5 to the power of x minus 9 is equal to 625. I'm going to write this in its lowest base form. So 5 to the power of x minus 9 is equal to 5 to the power of 4. Same base, which means that their exponents must be equal. So x minus 9 is equal to 4. Solve for the x. X is equal to 4 plus 9, which is 13. So as you can tell, the second method is easier. Use the method that best suits you. So if you have a poor understanding, decide on the method that would be best for that and would lead you to not having random error because of you forgetting something. But if you're good with logarithms, use a quicker method. Okay, next up we're going to be factoring x cubed plus 8. Okay, so for this one, what we're going to be using is the difference in the sum of squares. So let's just write that out. So the sum of, cubes. The difference in sum of cubes. So the sum of cubes is going to be a plus b into a squared minus ab plus b squared. So notice plus to plus in the first bracket, but in the second bracket, it'll be a minus. So it's going to be the opposite first sign when you hit it. But then this last plus b squared will always be plus b squared. So let's just expand to show you that it's true. And you expand this out, you get, use FOIL. So you should get a cubed plus b cubed. Okay. So this will become a cubed minus a squared b plus ab squared. Now do the b part, plus a squared b minus ab squared plus b cubed. Collect your like terms. This will become a cubed minus a squared b plus a squared b plus ab squared minus ab squared plus b cubed. Of course, these ones cancel, and it'll leave you with a cubed plus b cubed, showing that this relation is true. Okay, now let's also include the difference of cubes, just in case you don't know that yet. And that just states that a cubed minus b cubed is equal to, as I said, the first bracket, you match the sign. The second bracket, when you start, it's the opposing sign. And it's always plus b squared. That's the way to just quickly remember how to pull it out of your brain when you see it and apply it. Now, let's just prove that it's true. Again, utilize FOIL. This will give you a cubed plus a squared b plus ab squared minus a squared b minus ab squared minus b cubed. Collect your like terms. This will become a cubed plus a squared b minus a squared b plus ab squared minus ab squared minus b cubed. These two cancel, leaving you with a cubed minus b cubed. So you can tell the relation does hold. It's always great when you see a derivation, be it in math or chemistry or physics. Try and run through it yourself. It helps it stick in your brain because it isn't just information that you don't have a grounding with. When you truly understand how it works, why it works, or run into problems during the derivation, it's going to make it easier for you to remember when you do actually apply the rule. So now I need to figure out what our a and b are. So we have x cubed plus 8, right? Now the cube root of 8 is going to be 2. So 2 cubed is equal to 8, which means we have x cubed plus 2 cubed, which means our a is x and our b is 2. So when we simplify it according to a sum of cubes, we have x cubed plus 2 cubed is equal to x plus 2, remember the same sign, and then x squared minus 2x. So the first one you do the opposite sign, and then plus b squared, so 2 squared. This will become x plus 2 into x squared minus 2x plus 4. And then you should always check if you can factor this any further. If you can, do so. If you cannot, leave it like that. So in our case, we can't factor it down any further. So we're just going to leave it like this, and that's going to be your final answer. Okay, next up we want to find the value of c that is going to make what we have into a perfect square. So for perfect squares, let's just think about what those are, just in case you don't know. So for the perfect square method, if I have x by x multiplied by bx Yeah. So if I have x by x multiplied by bx, I can turn it into almost a perfect square, which is where that name comes from. If I just multiply these two, I'd get xb by x, and that isn't a perfect square. But I can make it nearly a perfect square if I divide this b in half, this bx in half, and add each half one horizontally and one vertically. And so what that means is I will now have this and a little bit and a little bit on the other side too. And so almost a perfect square. And so what I'm going to be missing, I have x b over 2, x b over 2. And so I can see that it's almost a perfect square, but what I'm going to be missing here is going to be a square of b over 2 by b over 2, which is b squared over 2 squared. Now, this is just a visual representation. What's actually happening is based off of the fact that x plus a squared, a perfect square, is going to be equal to x squared plus 2ax plus a squared. And so this a squared is what I'm looking for in this case. And so I have x squared plus 5x plus c, which means 2ax is equal to 5x. You can cancel out both 5s. I have 2a is equal to 5, which means a is equal to 5 over 2. b over 2. And so that means a squared is going to be b over 2 squared, so 5 squared over 2 squared, and that's 10 over 4. So in my question, c is going to be 10 over 4. So the reason why you have b in this and 2ax here is just based off of the fact that standard quadratic form is ax plus bx plus c. And so in your c position, you would have b over 2 squared, because b would be 2a, and a squared is b over 2 squared. And so I hope that all makes sense for you. But your final answer should be 10 over 4. Oh, sorry, 25 over 4, not 10, because it is squared. Okay, next up, we are looking for the factored form of what we have here. So from what I talked about earlier, we know we can use quadratic formula or split it. So firstly, I need to change it into a quadratic. I can't use the same substitution I did last time. What I can do is pull out an x, so I'm going to do that. And I get x into 2x squared plus 4x minus 1. And then now from here, I can use quadratic formula to simplify what I have inside the brackets. So if I try to use product sum, I have -2, 4. The factors of -2 are -2, 1, or 1, -2, and those don't add up to 4. And so I clearly can't find it easily. And so that indicates I'm going to have to use a quadratic formula, and that's just -b plus or minus square root of b squared minus 4ac all over 2a. My a is 2, my b is 4, my c is -1. So this would become -4 plus or minus the square root of 16 minus 4 into -1 into 2, all over 2 by 2. -4 plus or minus the square root of 16 plus 8 all over 4. 16 plus 8 is going to give me 24. So this is negative 4 plus or minus the square root of 24 over 4. 24 isn't a perfect square, so I'm going to use square root properties that just state that the square root of a by b is equal to the square root of a multiplied by the square root of b. And so the square root of 24 is equal to the square root of 4 multiplied by the square root of 6. That's 2 by the square root of 6. So using that, I'll have my two solutions as negative 4 plus or minus 2 square root 6 over 4. When I simplify that, that becomes negative 1 plus or minus the square root of 6 over 2. And that's going to be it. So these are my 2x values. And so now when I plug it in so that I can have it in fully factored form, I will get x into x minus negative 1 plus square root 6 over 2. And I will have x minus negative 1 minus square root 6 over 2. This will give me x into x plus 1 plus root 6 over 2 into x plus 1 minus square root 6 over 2. I can see that that factor of 2 before the x cubed arises because of this 2, so I can decide to leave it like this or multiply the entire bracket by 2 if I wish to do so. And that's going to be it for this question. So you can leave it in this form, or you can have 2 over 2 and 2 over 2 here, or as 2x plus something, which is completely up to you. And that's going to be it for this one. Okay, next up I have an inequality. So with these questions, typically at the high school level, when you're taught things, it's so that you can learn how to use math as a tool. But math is exactly that, a tool to do things that are visualized and in real life, but simplified down to a simple expression like this that you know how to work with. That's the point of high school math, that you know how to work with the math. But it's really important that you understand what is actually going on. You can describe it in words, you can describe it graphically. That way, if you do happen to have the math down wrong, you can see where you went wrong and understand that the solution either makes sense or doesn't make sense for what's going on. So let's first do the math before we explain it. So for 2 minus 2x is greater than or equal to 5x plus 5. Let's first expand that out to become 8 minus 4x is greater than or equal to 5x plus 5. Okay, and then next up, we're just going to want to bring all the x's to one side and all of the real numbers to the other side. So we can bring 4x over here and the 5 over here. So 8 minus 5 is greater than or equal to 5x plus 4x. So 3 is greater than or equal to 9x. Sorry, it's greater than or equal to, this is plus. So this will become 8 minus 5 is greater than or equal to 5x minus 4x. So 3 is greater than or equal to x. That's going to be your answer. You can state it as x is less than or equal to 3. Okay, now what is going on here? I've solved the inequality, but what is the question really asking me for is what I need to understand. And so I can see that both of these are functions of x. So I have inequality that looks like this. And what this is asking me for is, when is the function g of x greater than or equal to f of x? So at what point are these two functions meeting? And past that point, is g of x greater than or equal to, depending on that, you'll get your answer for what x value at which g of x passes f of x, basically is what this is asking for. So before I go to Desmos, I can just solve this quickly in my head. I remember that the general form is y is equal to mx plus b, m being the slope. So for g of x, where I have 4x plus 8, and for f of x, where I have 5x plus 5, I can already see that this function is steeper than this function. And so if I have y1 and y2, and my two intercepts are 8 and 5, y2 is going to cross at the 8. Sorry. So the 1 crossing the 5 the 1 crossing the 5 is more steep, and the 1 crossing the 8 is less steep. And so let's label these y1 and y2. F of x is y1, g of x is y2. So as I said, what this question is asking for is, when is y2 greater than or equal to y1? And so I need to find out what point they meet at this x value, and y2 will be greater than y1 for x values below that. And so, as I said, just go to Desmos. Plus 5. Oops. Okay, so I see that they meet at x is equal to 3. And for values below 3 is where I have my y2 being greater than y1. And so my answer to this question by visual inspection is x is less than or equal to 3, which I had found by doing the math. And so that's going to be it for this question. Okay, and those are all of the questions I have for you today. I hope you enjoyed today's Q&A. If you'd like to be notified of when we do post more videos, be sure to hit the subscribe button and the bell right next to it so it can push your notification of when we do post. If you'd like to be able to post questions of your own, be sure to check out the links in the description so you can get access to the OneClass page where we do source our questions. This has been Marlyn from OneClass, and I hope to see you next time.